Alrighty friends, back to solving with radicals 5.4 part 2. Same process. We're going to be adding in some more aspects to that. Let's get it started. So on this first one, just like in the last ones, we want to have the radical all by itself on one side. So it looks like we already have that. So to get rid of it, we are going to square both sides of our equation. It got rid of that, leaving us with x squared on that side and a 7x plus 8 now on the right side. Since we have an x squared in our problem and an x, I'm going to set this equal to 0 and try to factor. So I'm not going to move that x squared because I want it to stay positive x squared. I'm going to move these two things. I'm going to subtract 7x on both sides and 8 on both sides, giving me 0 over there. And then none of those things can go together, so I'm just going to write it out. X squared minus 7x minus 8, and then equals 0. Now that I have it equals to 0, I'm going to factor. So I'm going to figure out multiply to be negative 8, add to be negative 7. So that would be negative 8 and positive 1. If you're to take those and set each part equal to 0, the first one is going to give you x equals positive 8. And the second one's going to give you x equals negative 1. Now, if we test both of those answers, we want to make sure that we do not have a negative under the square root. So let's check the first one, plugging it in there, plugging in that positive 8. And that would give us a square root of 64, so that answer is okay. If we're to plug in the negative 1, that would give us a square root of positive 1. So both of these answers are okay and good to go. All right, let's solve this one. Same process as we did on the last one. We want a square root by itself on one side, so we can get rid of it by squaring each side of our equation. So let's do that. On this left side, it's just going to cancel and leave us with 10 minus x. On the other side, we need to do a little multiplying out because x plus 2 squared is x plus 2 times itself. So let's multiply that out. X times x will be x squared. X times 2 is 2x. And 2 times x will be 2x again. And 2 times 2 is 4. So I can put those middle terms together, giving me x squared plus 4x plus 4. Again, I got an x squared and an x. So I'm going to set this equal to 0 and solve by factoring. So I'm going to leave the x squared positive. I'm going to move this stuff over, giving me 0 now on that side. And 4x plus 1x would be 5x. 4 minus 10 would be negative 6. So we're looking for two numbers that multiply to be negative 6, add to be 5. Which if we do that, it would have to be positive 6 and negative 1. Those would multiply to be negative 6, add to be a positive 5. Careful on ones like that. The multiply to be 6, add to be 5 can really throw you off. Okay, now we're going to take each of those, set them equal to 0. On this one, it's going to give you negative 6. On this one, it's going to give you positive 1. Let's check underneath our square root. If we plug in the negative 6, 10 minus a negative 6 would be a square root of 16. That's okay. And if we do the 1, 10 minus 1 would be a square root of 9. So both of these answers are just fine. All right, looking at this next one, this is a little different than the ones we were just doing. We don't have a square root anymore, but we have this crazy exponent. So this is something we gotta figure out a different method on. To get rid of a square root like that, or a exponent like that, you are going to put each side to the exponent of the reciprocal. So I'm going to do an exponent of 2 over 5 on both sides of that equals. So I took that original exponent, flipped it upside down, So instead of 5 over 2, 2 over 5, and did that exponent on both sides. It gets rid of the exponent over here, leaving me with just x squared plus 5x plus 5. And on the other side, I can type that into my calculator. 1 to the exponent of 2 over 5. If you need to do that, make sure you're hitting that caret button, 2 divided by 5 in the exponent. It gives you 1. Fabulous, wonderful. Now we can do exactly what we did on our other ones. We can set it equal to 0 and try to solve by factoring. So I'm going to subtract 1 on both sides. Give me that 0 over there. And that's going to give me a 4 now. So I'm trying to multiply to be 4, add to be 5, which would be x plus 4 and x plus 1. So let's take both parts, as always, set them equal to 0, and we can find our answer. So the first one will give us x equals -4, and the next one will give us -1. Since we don't have any square roots, we're okay. None of our answers are going to be not possible. All right, let's practice that. On this one, let's look at it for a second. We have a little bit more work we got to do before we worry about that exponent. So just like with square roots, we needed the square root alone to get rid of it. We need this exponent situation alone before we can get rid of it. So I need to move this 2 that's in front and this -3. So just kind of like you would normally do if it was like 2x minus 3 equals 15, you're going to get that x alone, that x, all that stuff. So I'm going to add 3 on both sides to get rid of that. And all this stuff is left, equals 18 now. And then I'm going to get rid of that 2 by dividing by 2 on both sides. Still all this stuff over here. We're going to get rid of it in a second. And 18 divided by 2 is now 9. Now that we have that exponent alone, we can get rid of it. So I am going to do the reciprocal exponent on both sides. So the exponent right now is 1/2. I'm going to do an exponent of 2 over 1, or just really 2 on both sides. So by doing that, these are gone. And 9 to the exponent of 2 over 1 is 81. Again, let's just set it equal to 0 and start to solve. So I'm going to subtract 81 on both sides. And I'm going to start to factor. This one's a tough one. Use your calculator. Multiplies to be 85, adds to be 12. If you need to write your numbers that multiply to be 85, so like 1 times 85, it's divisible by 5, so 5 and 17. Oh, wait a second. 5 and 17 could get us to be 12. So that would be a -17 and a +5 to be -12. There we go, that worked. So setting both parts equal to 0, the first one would tell me x equals +17. Second one tells us -5. All right, let's do the next problem. Here we go. This one is very different. Now we have 2 radicals. Okay. So when we have 2 radicals, I want a radical on each side of the equals. That will be a lot easier to deal with that, I promise. So I want a radical and a radical. I don't want them both on the same side. So to fix that, I'm going to add this one to the other side, just so I have a radical on each side. So now on this side, I just have this one. And on the other side, I have 3 plus this. So I got one of my radicals completely alone. By doing that, I can get rid of it by squaring it, squaring both sides. So I got one radical completely alone, just like we've been doing on all the other problems when we had radicals. Very similar. So on this side, the left side, it's now just an x plus 9. Super nice. The other side's a little bit more of a hot mess. We need to write it out. So we have a 3 plus 2 square root of 2x times another 1. So let's multiply it out, do some distributing, see what it gives us on the side. 3 times 3 would be 9. 3 times a root 2x would be this. Do it again. That would give us another 3 square root of 2x. And then a positive root 2x times a positive root 2x would be positive. And when we multiply the same thing underneath the square roots, it just comes out. So it will be 2x. Just like if I did square root of 5 times square root of 5, it's 5. Same thing with this one. Okay, so let's put together those like terms in the middle and write it over there back in our problem. So the 9 stays a 9. Now we have plus 6 square root of 2x, and then a plus 2x on the end. Now, we're going to kind of repeat this process. I know that sounds weird because we still have this square root. I want to get that square root alone because in order to get rid of it, I have to square it. So I want to try to get that square root as alone as possible. So I'm going to do that. I'm going to subtract 9 on both sides. That's really nice. Those both cancel. And I'm going to subtract this 2x also. So I got a negative 1x. And I'm going to leave this over here for a second. Now, some of you might be thinking, hey, why don't we divide by 6? Get rid of that number in the front. If I do that, it's going to start to give me a fraction, and I don't really personally want to deal with fractions. So I'm going to get rid of that square root. So I'm going to take this, and I'm going to square each side. Whew, this is a tough one. If you're struggling, it's okay. Keep following along. You're doing great. On this left side, it is a negative 1x times a negative 1x, which will be a positive 1x squared. On the other side, it is a 6 square root of 2x times a 6 square root of 2x. The 6 times the 6 is 36. Oops, what am I doing? 36. And we just talked about if we do a square root of 2x times a square root of 2x, it's 2x. So really, 36 times 2 would be a 72, 72x. Whoa, a lot just happened. Okay, now that we did that, we're gonna set it equal to 0 and try to factor it. So I'm gonna leave that a positive x squared, and then I'm gonna subtract this on both sides. So we have 0 over there, and we got this now all on one side. Now it's not a normal factoring situation because we don't have like an x squared plus an x plus a number. We do, however, have a greatest common factor. I can take an x out of both of these. So if I do that, I'm left with x minus 72. Whoa. That was crazy. Now, we're going to take both of those, set them equal to 0. So the first one would just be x equals 0. And the next one would be a positive 72. Now you can go back and plug those into the square roots. They do not give you a negative square root, so they are both okay. Last example, it's very similar to the last one. If you want to pause and try it out at least to see if you're getting the process, looking back at the old one and working it through yourself, I would do that. If you're really unsure, follow along with me. Okay, so the first thing we did on the last one was we got one of the square roots alone. So we moved one of the square roots over to the other side. So I'm going to do that. I'm going to move this square root to the other side. And by doing so, now I can get rid of that square root from this one by squaring each side of my problem, which gets rid of my square root, leaving me with x plus 3. And then we need to do a little side work to multiply out or square the second one. So multiply it all out. This is a lot. So make sure you're writing not too big. Okay, let's do it one at a time. 1 times 1 is 1. 1 times an square root of x plus 1. Same thing right there. Another one of those. And then multiplying those together would just make it come out, giving us an x plus 1. Whoa, lots of things that we can put together. The ones can go together to give me 2. These can go together. 1 square root of x plus 1 plus a 1 square root of x plus 1 would be 2 square roots of x plus 1. And then don't forget about that lonesome little x back there. It's still there. Don't lose it. So since we still have a radical, we still are trying to get that radical alone so we can square something. So I'm going to try to move some stuff. I'm going to move this. That would help us get that square root alone. And I'm going to move this x. Oh, that's nice. So those are gone, and that's gone. So we're left with 1. And we're left with this. Now again, I wouldn't divide by 2, because then it's going to give you a fraction on that left side. We don't want that. So I'm going to square each side to get rid of that square root. So 1 squared on the left would just be 1. And let's write this one out to the side. 2 squared of x plus 1 times another 2 squared of x plus 1. 2 times 2 is 4. And square root of x times the square root of x would just be x plus 1. It kind of comes out of its little square root. Oh, that's really nice. We don't even have x squared, so let's distribute that. 4x plus 4. Oh my gosh, this is great. We don't even have to factor. We can just solve. There's no x squared in this problem. So I'm going to subtract 4, giving me negative 3, and divide by that 4 to give me an answer of x equals a negative 3/4. Now if I plug that in, it's not going to give me any negative square roots. We're okay. Looks great. Head on over to that 5.4 worksheet number 2 and do some practice using your notes.